Hi, and welcome to a lesson on the sine rule. The sine rule is usually used for non-right angled triangles. Usually when it's a right angled triangle, we use trigonometry to find angles or sides, or just if it's just sides, Pythagoras. But the sine rule can be used for both, and usually it is related to solving problems with non-right angled triangles. And usually the way that I like to identify whether or not I'm going to use the sine rule is whether or not we know a pairing. So a pairing, by that I mean I know the size of an angle and I also know the length of the opposite side. Okay, so we know a pairing. Okay, an angle and its opposite side. That's how you would know whether you're looking at a sine rule problem. We also can label this angle perhaps B, side length B, angle C, side length C. Now, if we're trying to find side lengths, so to find side lengths, what we do is we use this version of the sine rule, which is A over sine A equals B over sine B equals C over sine C. And all we do if we're trying to find angles, we'll see this in action soon, is that we just invert this. We put the angles on the top. So we get sine A over A is sine B over B is sine C over C. Okay, so let's see it in action then. Here is a non-right angle triangle. We know a pairing, we know 60 degrees, and we know 7 for its side length. And so I'm going to label these as, I'll go for B, the small b, and this can be side length A that I'm trying to find in my question, length of X, and angle A. Let's put those into the sine rule. The sine rule says that A over sine A equals B over sine B. So I've labelled up the lengths A and B. It's random, I could have done it the other way around, and the opposite angle to each is the same letter. I'm trying to find X. Let's put these things in. A is X, so X over sine 80 is equal to 7 over sine 60. And now I'm trying to make X the subject of this, so all I need to do is to multiply by its denominator to get it on its own. So multiply by sine 80, multiply by sine 80, and I get that X is equal to 7 over sine 60 times sine 80. An alternative way of writing that, or easier perhaps putting it into a calculator, is 7 sine 80 over sine 60, because anything times by a fraction just is multiplied by its numerator. And so what I get then, if I put that into my calculator, being really careful that I'm in degrees, not radians, 7 sine 80 divided by sine 60 is equal to 7.96, which I can look at and think, yeah, looks quite sensible, doesn't look out of place there. It's not wildly different from the other sides that I know, or the 7 that I know. Yeah, and there's no units, so I'll just leave it there. So 7.96. If you would like to have a go a bit more independently, here's another example. So feel free to pause the video, but I am going to be going through this now. So let's have a look at one more with finding the side length. Here's the sine rule, just with two, I know a pairing. I know this pairing, should I say. I'm trying to find P. So we can say that 21 over sine 95 is equal to P over sine 32. All I need to do at this point is to times by sine 32 on both sides, and I'm going to get that 21 over sine 95 times by sine 32 equals P, and therefore P, if I just simplify that a little bit, 21 sine 32 over sine 95, keying very carefully again into the calculator, and we get an answer of 11.2 to 3 significant figures. Again, looks okay to me. I'll accept that one. And I've done my sine rule correctly. Okay, let's look at finding angles next. Now, as I said before, all we need to do at this point is just to invert the sine rule. So there we go. Okay, might want to label up. We'll call this one A, B, and B. Okay, I'm trying to find angle M, so sine M, because A I've labelled the M with A, over its opposite side length, which is 8, is equal to sine 75 over 10. Okay, now there's actually two steps that I need to take at this point. This first one is like before, I'm just going to times by this denominator of 8 to get the sine M on its own. So sine M is going to be 8 sine 75 over 10. And then there's just one more step. When I've got that answer in my calculator, all I'm going to do then is inverse sine it. Okay, so I always use my answer button. So 8 sine 75 over 10. So I'm going to put that into my calculator, 8 sine 75 divided by 10, and then I'm going to inverse sine answer. And I get an answer of 50.6 degrees. And usually 50.6 degrees is one decimal place, isn't it, for angles? One more example, just like that. Have a go yourself if you're feeling confident. I will go through it. Feel free to pause, beat me to the answer. Okay, there we go. So we've got A, small a, B, small b, trying to find b. Okay, perhaps I should have done it the other way around. It doesn't really matter. So sine 100 equals 5.1 equals sine b over 3.6. First thing I want to do is get the sine b on its own. So I'm going to multiply both sides by 3.6. And I get 3.6 sine 100 over 5.1 equals sine b. And now the last job I've got to do is just to bring the sign over here by making inverse sine. So b is sine to the minus 1 of the left-hand side, sine 100 over 5.1. Okay, so being very careful again, 3.6 sine 100 divided by 5.1, and then I'm going to inverse sine my answer. And I get an answer of 44.0 to one decimal place degrees. Okay. I hope that that's been really nice and clear and that you've enjoyed my video. If so, tell your friends, subscribe to the channel, support me, and I hope that you have a wonderful day.